Welcome to The Explainer. Today, we're diving into how to build faster, way more responsive applications using Java's powerful concurrency tools. We're going to see how you can take your code from just doing one thing at a time to handling millions of operations at once. Yep, millions.
So, let's kick things off with a problem I'm sure you've all felt. You know that feeling? An application that just freezes up, a website that hangs, or some process that seems to take forever. Well, a lot of the time, that's because it's stuck doing one single thing at a time, completely wasting all those powerful multi-core processors we have these days.
All right, so here's our game plan. We'll start with the basic single-threaded problem, then jump into managing threads intelligently. After that, we'll cover how to get results without just waiting around, explore the lightweight future, and finally, wrap it all up into your modern concurrency toolkit. Let's get to it.
Okay, first things first, let's really get to the heart of the matter, the big, fundamental bottleneck that concurrency was literally invented to solve.
The best way to think about this is like traffic. A single-threaded application, that's a one-lane road. One car, one task, has to finish its whole journey before the next one can even start. You can imagine that's going to cause a massive traffic jam. But multi-threading, now that's a multi-lane superhighway. You've got multiple tasks running at the same time, which is a total game changer for anything that involves waiting, like network calls. It keeps your whole application feeling fast and snappy.
Okay, so we've got our superhighway, but what's the one thing you need on a busy highway to prevent total chaos? Right, you need some smart traffic management. Here's the deal. Just spinning up a new thread for every tiny little task is incredibly inefficient. It's a huge drain on system resources. And trying to manage them all by hand? Oh, that's just a recipe for disaster. Luckily, Java has a way smarter approach.
And that brings us to the executor service. This is the key. Think of it like a crew manager on a job site. Instead of hiring a new worker for every single nail you need to hammer and then firing them, which would be crazy, you have a dedicated crew, a pool of workers ready to go. You just hand your manager a list of jobs and they handle assigning them. It's efficient, it's clean, and it puts a nice cap on resource use.
And actually, using it is super straightforward. It's basically a three-step dance. 1, you create your pool. 2, you submit your tasks. And 3, and this is important, you shut it down gracefully when you're done. That's it. You get all the power of multi-threading with none of the usual headaches.
All right, this is great. Our tasks are humming along efficiently in the background. But this brings up a new question. What if those tasks need to return a result? How do we actually get that data back to our main application?
Well, when you submit a task that's supposed to return a value, the executor service instantly hands you back something called a future. And it's exactly what it sounds like. It's a promise, a little placeholder for a result that isn't ready yet, but it will be, eventually.
But, and this is a huge but, there's a catch. To get the actual value out of that future, you have to call its get method. And guess what get does? It stops everything. It blocks. Your main thread just sits there and waits, and suddenly your whole app is frozen again. We are right back to the problem we were trying to solve in the first place. So clearly, that's not ideal. This whole blocking problem is precisely why Java introduced a much more elegant, modern solution for handling these kinds of results.
And that is the complete future task. This thing is a total game changer. It flips the whole model on its head. See, instead of you constantly poking it, asking, hey, you done yet? Is it done yet? You simply tell it what to do when it's done. You attach callbacks, you build a chain of operations, and everything just flows automatically as the results become available. No blocking, no waiting. It's beautiful.
And the stuff you can do is just awesome. You can chain tasks that depend on each other, combine results from two totally independent tasks, apply transformations, handle errors, all of it in this really clean, readable, non-blocking pipeline. It makes building really complex async workflows surprisingly easy.
So, we've leveled up. We've gone from one thread to managing hundreds of them efficiently. But what if hundreds isn't enough? What if your application, like a modern microservice, needs to handle not hundreds, but thousands or even millions of concurrent operations? That's a whole different ballgame.
Enter virtual threads. This is one of the biggest game-changing features in Java in years. These are not your traditional heavy operating system threads. Nope. These are incredibly lightweight threads, managed directly by the JVM itself. And they're designed for one thing: applications that spend most of their time waiting for a database, a network response, a file, you name it.
And because they are so lightweight, the difference in scale is just staggering.
With traditional threads, you might be limited to a few thousand. With virtual threads, you can create millions of them without exhausting your system's memory. This unlocks a level of concurrency that was just impossible before.
All right, let's bring everything together and assemble our modern concurrency toolkit.
Here is the takeaway. These three tools are the core of modern Java concurrency. Use an executor service when you need to manage a controlled pool of threads for general-purpose tasks. Use complete future when you need to compose complex, non-blocking, asynchronous workflows. And when you're building high-throughput applications that need to handle massive scale, you reach for virtual threads. It's all about picking the right tool for the job.
So, now you have the toolkit. The next time you see a bottleneck, a slow response, or an opportunity for parallel work, you can think back to this. Are you managing a handful of heavy tasks, composing a complex data pipeline? Or are you handling a flood of incoming requests? The right tool is now in your hands to make your applications faster, more efficient, and more scalable than ever before.